Okay, so this is the first video I've been able to record with my pin working properly, so this will be kind of exciting. Okay, so we have this PDE. Our range is x, our domain is x is greater than or equal to y, and x is greater than or equal to 0. Our Cauchy curve is going to be given by here, u of xx is equal to 1 plus x. So let me draw some stuff. So x is greater than 0 and y is greater than x. So we're only looking in the first quadrant. That's the normal x and y axis. Okay, now if I look at y is equal, so y less than or equal to x. So if I look at y is equal to x, that's going to be this line right here. This line is y is equal to x. And we only care about the solution in this part of the plane. And what is our information? Well, we know u of xx is equal to 1. So on this line, 1 plus x, we know u is equal to 1 plus x on that line, and we know it's equal to 1 on this line. So actually, this is the Cauchy curve. Okay, and so this will be similar to the previous problem. Our x naught and y naught is going to sort of depend on where the characteristic starts from. So let me just write out what the characteristic equations are going to be. X dot is equal to 3, and I'll just put a generic x naught there. Y dot is going to be equal to 1, and I'll just put a generic y naught there. If I think about my PDE, if I rewrite it, this is 3 times the x derivative of u plus the y derivative of u is equal to minus 2u. So then z dot is going to be equal to minus 2 z of s, and this is going to be equal to, well, I'm just going to write u of x naught, y naught. It'll depend, again, this will depend on whether we're looking at x naught, on what our x naught, y naught point is. Okay, so now, again, similar to the previous problem, there's going to be separate cases. Let's see, we're going to have one case, I'll do it in black, where our characteristic starts here. Whoops. Not what I wanted. Hold on. Okay, for a characteristic, this say starts here on this line. We're going to go over 1, 2, 3, and up 1. So we're going to look at something like this. We'll look at this arbitrary point AB. But then for a line that starts here, okay, 1, 2, 3, up 1, we'll have something that looks like this. Okay, these lines are parallel even though it doesn't look like it. I see now because I drew that one wrong. Okay. I went up 2 instead of 1. All right. So 1, 2, 3, up 1, like that. Okay, now those lines look a little more parallel, AB. Okay, so now we can start, or keep going, I guess. So z dot is equal to minus 2z. This gives us z of s is equal to z of 0 e to the minus 2s. Okay, now let me do the top part first. So if I'm on this line right here, if I'm on this black line, and AB is an arbitrary point, then, and this point right here, we'll call it x naught. X naught, because on that line, that's the line y is equal to x. So u of AB is going to be equal to z of 0, which is u of x naught e to the minus 2s. Now if we're on that line right there, we know that u of xx is equal to 1 plus x. So this is going to be equal to 1 plus x naught e to the minus 2s. Now given an arbitrary a and b, I need to figure out what x naught and s are. So a is going to equal to 3 plus x naught, and b, 3s plus x naught, and b is going to be s plus y naught, but along this line, x naught is equal to y naught, so this is going to be s plus x naught. Okay, so now I need to figure out what a and b are. So there's a number of ways to do this. If I subtract equation b from equation, if I subtract the b equation from the a equation, I get a minus b is equal to 2s. So s is equal to a minus b over 2. So I can write this equation as a minus b over 2 plus x naught. This tells me x naught is equal to b minus a minus b over 2. Okay, so this is, if I get a common denominator, this is 2b minus a plus b over 2, which is equal to 3b minus a over 2. So that's what x naught is. So then this is going to be 1 plus 3b minus a over 2 times e to the minus 2s. So this is going to be e to the b minus a. Okay, now if I look at the red, an arbitrary point on the red line there, well, still my general formula is going to be u of AB is equal to u of x naught y naught. Okay, here x naught is just arbitrary and y is 0 times e to the minus 2s. Okay, so the function along the x-axis is just 1. U of x0 is equal to 1. So let me make this y naught 0 now, since we know that it's 0. So that's u of x naught 0 is going to be 1. So I just won't even write that. So this is going to be e to the minus 2s. And for this equation, I know a is equal to 3s plus x naught, and b is just equal to s plus x naught. Or sorry, s plus y naught, which is just s. So in other words, this is equal to e to the minus 2b. So overall, my solution is going to be equal to 1 plus 3b minus a over 2 times e to the b minus a if we're kind of in that upper region, and then if we're in that lower region, it's just e to the minus 2b. Okay, and what is that dividing line? Well, that dividing line, like where these two things, where you switch from being in the top region to the bottom region, that's going to be along the line y is equal to 1/3 x. So 1. So this line is y is equal to x over 3. So this is going to be for y greater than or equal to x over 3, and this is going to be y for y less than x over 3. And observe actually when y is equal to x over 3, sorry, this I should have this in terms of b. So this is b greater than or equal to a over 3. And then this is going to be b less than a over 3. Notice when b is equal to a over 3, both the formulas, the top formula and the bottom formula, are equal when a is equal to b over 3. So we could even do that right there, and it wouldn't be ambiguous or anything like that. Okay, so that is the solution for this problem. There we go.